talk about the answers. You do not have to write this down. This is not bell work. We're just having a class discussion. So for this, if I show you this craziness, can anybody, without using the midpoint formula, anybody look at this picture and tell me what coordinate point is the middle of the line? Tell me. What's the coordinate? 1, 0, 1. So right there in the middle, that would be in the middle. You know that because you have eyeballs and you're like, that's the middle because that makes sense. You're correct. Okay. We didn't have to use the midpoint formula because we have eyes. Okay. If I wanted to know can you determine where 1/4 of line segment AB is? So if I start at A and I go to B, where would the point of 1/4 of the way fall at? Can anybody tell me? -2, 0. So right there. So -2 zeros right here. Because if you think about it, if this is in the middle, you could technically use slope to cheat the system. You could say I'm rising 1, running 2. That's a perfect point. Rising 1, running 2. That's a perfect point. Rising 1, running 2. So this would be 1/4 of the way from A to B. What about if I want to go 1/4 of the way from B to A? Where would that fall? 2. At 2, 2. 2, 2 right here would be technically 3/4 of the way if I started at A and went to B. But if I started B and go to A like it asks for, 1/4 of the way would be right here. This is technically called partitioning. So if these questions were on your midterm and it was multiple choice, you could use your brain to figure out the correct answer without actually using the formula. Now, these are really nice numbers that I use, like 1/4 and whatnot. Normally, they're going to give you like 5, 6 or something like that. But then you should be able to eyeball like, okay, this one's way closer to A. It should be close to B. Like, let me choose the one that's close to B. Okay. So this is what we're doing today, but like mathematically with a formula. Okay. So on here, the first thing I want you to write off to the side, bless you. Off to the side in this little open area is what partitioning actually is. To partition something. So partition means to divide something or to divide into pieces. Yeah, I write with a pen because if I write with a pencil, you can't see it. Who's writing with a pen? Oh boy, you're probably gonna want a pencil. Do you want a pencil? Are you sure? Okay. Okay, so partition means to divide something into pieces. So when I say we're partitioning, that means we're figuring out what 3/4 of the way where that coordinate point is going to lie on the line. So the first thing that we're going to do is we're going to assume that the segments partitioned in, or these are partitioned into congruent parts. We're going to write each thing as a ratio, which is like from way back when. So I have a little line segment. It means that each individual piece is congruent. So there's 3 parts. Okay. If I say from A to P to P to B, A to P is technically 1 piece. P to B is how many pieces? 2. So you would write your ratio as 1 to 2. And you could use the word 2. You could technically write it as a fraction, or you could use the little colon. Okay, let's do the next one. It says A to P to A to B. So A to P is 1. What about A to B? 3. So this is technically 1:3. And then the way we're going to write this is 1/3 for this one, because this is how we're going to write it today for our math equations. You're going to need it from piece to whole line segment. So if they give it to you like this, you're going to have to rewrite it like this. So this is kind of like a little warm up. So the next one, if I say AP to PB, how much is A to P? 5. Oh, I don't want to use blue. So this is 5. And then how much is P to B? 3. So this would be 5, 2, 3. The last one we're going to do is AP to AB. So if I go from A to P, that's still 5. What is A to B going to be? 8. So the way we're going to write this is 5 little colon 8. And because this is technically piece to whole line, which is what we're going to need to do all day today, we're going to write it as 5/8. So this is how we're going to have to write our ratios. So if they give it to us piece to piece, we're going to have to change it piece to whole. Okay. So what all this means, all of this, you could read this on your own time. I'm going to explain this to you. Basically what we're going to do, step one, we're going to write our ratio. We're going to change our ratio that's given into piece to whole. Okay. So we're going to make it into a fraction. Then what we're going to do is technically we're going to calculate how much we rise and how much we run to get to the other point. We're going to multiply it by the ratio, and then we're going to add the initial point, which when I'm talking, you're like, what in the world is she talking about? Okay, so we're just going to do a couple problems. It's going to be okay. This is the only paper we're getting today, so bear with me. Okay, so numero uno says, given the directed line segment A to B, says directed because you're going in a direction. You're starting at A, you're ending at B. Find the coordinates of P such that the ratio of A to P to B is 1/3 or 1 semicolon, whatever, 3. Plot the point P. Okay. So first thing I wanted you to do is write where we start. So at A, that's where I'm starting. What is the coordinate point where I'm starting on the graph? And I'm sorry, there's no numbers. -5, -1. Okay, so that's my starting point. That's important, okay, because sometimes you'll start at A, sometimes you'll start at B. So you have to go in the right direction. Off to the side, let's draw a little line. I know I have A and I have B. I know point P is somewhere in the middle. It's not exactly in the middle, but P is between them. And I'm going to kind of make this into the ratio. So it says A to P, the first two letters represents the first number in the ratio. So A to P is 1. Boop. And it says P to B is 3. I need to change this. This is part to part. I need to change it to part to whole. So instead of 1/3 or 1/3, what would this actually be if this piece is 1? What would the whole piece be? 4. So the fraction I'm actually going to use is 1/4 because there's 4 total pieces. So it's called your K, which is your ratio, is 1/4. Okay. So we basically want to know where 1/4 of the line is from A to B. We're going to do this mathematically. You could try to figure this out on your graph, but I want to show you the proper way to actually do it as well. Okay, so the first thing we're going to do is we're going to talk about X, which is your run. Think about rise and run. Y is technically your rise because you rise on your Y. Okay, so from A to B, how much do I have to run across my graph to get to B? No. From A to B, how much do I have to run across? Well, good. So my run is 12. How much from A to B do I have to rise? How much? No. 8. You were slightly off. It's okay. So you run 12, you rise 8. Now, if I run 12 and I rise 8, that means I'm going all the way to B. I don't want to go all the way to B. I want to go 1/4 of the way from A to B. Okay, so instead of going over 12, I'm going to take my ratio, which is 1/4. I'm going to multiply by 12 because I want to go 1/4 of the way. What is 1/4 times 12? And if you're not sure, use a calculator. It is what? It's 3. Okay, good. Now, technically that means from point A, I need to go 3 over. Okay, so to mathematically figure out where I'm falling at, you're adding the initial point. I started at -5 on the x-axis, so I'm going to add -5 to this number. So 3 plus -5 is technically -2. That is the x value of my coordinate point. I'm going to do the same thing for y. I ran a total of 8. I want to go 1/4 of the way. So I'm doing 1/4 times 8, which is 2. And I'm adding where I actually started at on the graph, which in this case is -1. That's why I wrote out the initial point. That's where I'm starting. That's the value that I'm using. So I'm adding -1, which is technically what? 1. So P, the partition point, is at -2, 1. I want you to add that to your graph. It should fall on your line. So take a second, plot your point. What the heck? That is the answer. It's going to make sense, and we're going to move a lot faster than like that. I'm just trying to like explain to you that this, you're starting at A, you're going 1/4 of the way. So it should be closer to A because you're only going 25% of the way, okay? So that is technically where it's partitioned at. You could figure this out by playing with the graph and playing with the numbers in your head, finding the middle and then splitting the middle in half again because you want to go 1/4 of the way. It's going to be multiple choice. So then you could also look at all the possible answers and be like, oh, well, it's got to be closest to A. And that looks like it's like 1/4 of the way. What's up? Yes. Oh, wait, do you let her go first because she wanted to go first? You can go. Bring me your phone. And then once you get back, go. Okay, let's try number 2. So number 2, same thing. It says, given the directed line segment R to T, below, find the coordinates S such that the ratio of RS to ST is 5:1, plot point S. So let's figure out where we're starting. We're starting at R because it says R to T is my direction. A lot of people would look at this graph and be like, I'm starting at T because I'm going from the left to the right. You're starting at R. So what is my original coordinate point for R? Good, 7-1. Boop. Okay. Off to the side, I'm just going to kind of draw a little sketch. I know RT is my segment, and it says S is on the middle, or like in the middle, not in the middle, but find the coordinates of S. So S is like my mystery point. So I'm just going to put S somewhere here. And then it tells me the ratio of R to S is 5. And it says S to T is 1. So that's part to part. I need to change it for my fraction from part to whole thing. So what would be that fraction? 6. So my K, which is technically my ratio, my fraction I'm using is 5/6. This is why it might be a little bit harder to use, just figure it out on the graph because you're going 5/6 of the way instead of something nice like 1/2, 1/4. So I have to go 5/6 of the way. I know I'm going from R to T. So should my point be closer to T in the end, or should it be closer to R in the end? It should be closer to T because I'm starting at R, I'm leaving R, I'm going to T, and I'm going 5/6 of the way. So it should be somewhere over here. And that's where whenever it's multiple choice, you can kind of look at your answer options and kind of cheat the system. But we're not going to cheat the system today because we're learning. So X, I have a Y over here. X is how much I'm running. Y is how much I'm rising because you rise on your Y, just like slope. So for my run, if I start at R and I'm going all the way to T, how much did I have to run to the left? 12. And since I went left, I'm going to say -12 because I went to the left on the graph, which means when I'm going left, I'm going backwards, which is negative. How much did I have to rise, or how much did I have to go down? 6, so -6. Okay, so the idea is, the concept behind this is I don't need to go the whole distance. I do not need to go the whole 12 to the left. I do not need to go the whole 6 down. I need to go 5/6 of that amount. So I'm going to take my K, which is 5/6, and I'm multiplying by the entire distance because I don't need to go that whole distance. I need to go 5/6 of the way. So in a calculator, because you guys hate fractions, there is a fraction button, which some of you do not know. 5/6 is 5, and then you can press the ABC button. This ABC button will come in handy. So ABC, that little weird thing pops up. That means it's 5/6, and you're multiplying by -12, which if you don't know in your brain, That's negative 10 because technically 6 goes into 12 2 times. 2 times 5 is 10. But if you don't know it, it's okay. People freak out when there's fractions. So you get negative 10. And then I'm technically adding where I started. So what x value did I start at? 7. So I'm going to add 7 to it. So that gets me negative 3. So that's the x value. I'm going to find the y now. So I'm going to go 5, 6. What am I multiplying 5, 6 by? Perfect. What am I? Oh, okay. Well, so in your calculator, if you don't know fractions, it's okay. Use your calculator. 5, 6. Yep. Times negative 6 is negative 5 because the 6's really cancel. And then what am I adding to it? 1, because that's where I started. So plus 1. Boop. And then that makes negative 4. So S is technically at negative 3, negative 4. Add that to your picture. And it should be closer to T because it's 5/6 of the way from R to T. So negative 3, 1, 2, 3, 1, 2, 3, 4. Boop, boop. There you go. So I want you to try number 3. Just try figuring out where you're starting and try to draw this little picture to help you change your ratio that's given into the ratio that you need to use. Thank you. Yeah, just there. So start with that because I don't want you to do the whole thing wrong with using the wrong ratio. So start by figuring out what point you need to start at, write your start point, and then draw your little picture off to the side and try to find your new ratio. So try number 3. Try to figure out where you're starting and try to write your little graph over here so that way you can figure out what fraction you're using. You don't have to do the whole thing. I'm going to talk about that before you try the rest of the problem. Okay, so does anybody know the point where I'm starting at? Good. Okay, so we're starting at J. What is that coordinate? Nope. Yeah, negative 6, 5. Because you're starting at J. I know I know. I'm sorry. These don't have line or numbers. And then they're all the same. It's really like playing with your eyeballs. But you're starting at negative 6, positive 5. Okay. And then you should have went over here and drew a little line. You have J and L at the ends because that's what it says. What is that? K is somewhere in the middle. Okay. And then it says the ratio of J to K is 7. So J to K is 7 pieces. And then J to L is 8. So actually 8 goes all the way across. So this time they didn't give me piece to piece. What would be my fraction I would be using in piece to whole? It is not 7/15. Whoa, what? Nope, we're not using 15. Not -6. 7/8. Because normally, sometimes they're going to give you piece to piece, and you have to change it piece to whole thing. Same thing here. It gave us piece to piece. So there was 5 and 1. I had to change it from piece, which is 5, to 6, which is the whole thing. This time, they actually made our lives easier. They gave us piece to whole. So I don't have to change it to 7/15. It's already giving me my K, which is my ratio of 7/8 of the way. So basically, from J to L, I need to figure out where 7/8 of the way is going to be. It should be closer to L because I'm starting at J, I'm ending at L. So instead of going the whole run and the whole rise, I'm going 7/8 of the way. So take a second. I want you to try to figure out how much you're running. That's your X. And try to figure out how much you're rising, which is your Y. So count your little boxes, see how much you're running from J to L, and then see how much you're going down from L or whatever, from J to L. Thanks. I'll just put it right there. That's 8 3/4. If you press the ABC button again, it'll give you a decimal. Okay, so how much did I run? How much? You're +8. Because you're going from J to L. So I'm going to the right. So that's positive. But then I'm going down. How much am I going down? 10. So it should be -10. When you're counting how much you're going, you're counting the first part where you start. Oh, and then you finish it. Two options. Okay, so run is 8. I'm going down 10. That's why it's negative. And now you have to think conceptually. I'm not going this whole distance. I'm going 7/8 of the way. But it's okay. You have a calculator. You do not need to do this in your brain. You're doing 7/8 times 8, which this one would be really easy to do in your brain because the 8s cancel, right? Hopefully we know that. If not, use the calculator. So you should get 7. And then what am I technically adding to it? -6, which is really just -6 because I'm starting at -6. So 7 plus -6 gives me 1. 7 minus 6 is 1. That should be your X. I'm doing the same thing for Y, but you should probably use the calculator so you don't hurt your brains. So I'm doing 7/8 of the way, but this time I'm multiplying by -10. So in the calculator, if I do 7, fraction button 8, 7/8, ABC is the fraction button. And this weird little thing will pop up. And then whenever you multiply by -10, you get something a little crazy. You get this. And what this means as a fraction is -8 is your whole number, and then it's 3/4. You don't have to press shift. If you literally press ABC again, boop, it changes it to a decimal. If you need a fraction, then you press it again, it goes back to a fraction. I don't care, whatever you prefer. I like decimals. I think they're better. So I'm going to put the decimal. So I'm going to do -8.75. And then how much am I adding to that? 5. But no, if they wanted you, say like the cycle assessment or the EOC, if they want a fraction, just use the fraction button. And then if you add 5 to it, it's going to still change it to -3 3/4. -3 3/4 is -3.75. So use that fraction button. Try to like play with it, get used to it because it'll help you in the long run. So that coordinate we're going to plot on our grid. Although it's not cute, it should fall on your graph. So if I go over 1 and down 3.75, it's this point right here. And this is why if it's multiple choice, you could be like, okay, 7/8 of the way, that's probably fine. If you don't remember how to use, like, how to do the math. Huh? This is like the worst thing that we do every single year. This is like the worst thing that people like hate. And then it'll be like the end of the year. And then people will be like, oh, partitioning. And I'm like, yep, it's still the worst thing out of the whole year is partitioning. Because it's just like
It's
weird.
a stupid name.
It is stupid. I don't like it either. But like, I don't make the rules. I don't make the rules around here. Oh,
Japanese.
oh my God, I know. I know. What? Like how? I
Well,
could
it's
never.
worse over there. They gotta be at school for like 15 hours. And like they have to
Are
clean
you being
up.
serious?
Yeah. They have like they stay until like 7 a.m. and then back the next day at 6.
Well, that's why they're smarter than us. Okay, anyways, so there is a formula for this. So what we did was we took our K. This is the only paper you guys are getting today, so we're almost done. So you take your K, and then technically what we do is we multiply by either the rise or the run. The rise and the run from a formula, if you look at your blue sheet from middle school, is technically slope. Slope is rise over run. To calculate your rise, you subtract your y's. To calculate your run, you subtract your x's. So we're going to say x2 minus x1 because that's technically our run. And then after we would multiply that, we would add where we started, which is technically x1. You do the same thing for your y's because it's a coordinate point. So you would take your k and you would multiply by your rise, which is y2 minus y1, and then you're adding y1. The reason why you should understand conceptually where this comes from is because this formula is not on your reference sheet anywhere. So the odds of you remembering this are kind of very rare, unless you have like a photographic memory, which is always like 1 or 2 people every single year that can like remember a bunch of formulas. This isn't on your reference sheet. That's why it's like, it's important that you understand like, okay, let me eyeball this. Let me see where this is kind of going. Let me try to like, just figure out from the options that they give me, what's the answer. Okay. So this is our formula that we're using. It's a coordinate point. So I just put a comma between them. So let's do number 4 without a graph. So it says given AB with A as this and B as this. A is where I'm starting. So A is x1, y1 because A is where I'm starting. So I'm literally going to call it x1, y1, x2, y2. I know, we're almost done. You're lucky I'm not giving you the second sheet I made. What? You're crazy. If P lies on AB such that the ratio of A to P, P to B is 2/3, find the coordinate. And you're like, what in the world? When in doubt, draw it out. So let's draw it out. Draw it out. AP is dose. Dose. PB is trace. Nope. Okay. That is part to part. I need to change it from part to whole. This is a 3. That's a 2. That will be 5. 2/5. So my K is 2/5 because every single time I need to change it from part to whole. There's 5 total pieces. The first number is always going to be the same. 2 is the same. Yes, if it does change. Yeah. Huh? Why? Oh, is that what that means? That means hungry? Oh, I thought that means like withering away to nothing.
Yeah.
Because of your hunger? Well, you still got another class period to go. I'm sorry. I mean, what do you want me to do? Should bring a little snicky snack. Okay, so we're going 2/5 of the way. So we're going to say 2/5. Technically, I'm multiplying by my run which is the difference in the x's. So I'm taking x2 and I'm subtracting x1. So 8 minus 3. But then I need to add where I started. So from the first coordinate, what am I adding? 3. Because it's positive, silly goose. I know. I show every single step while you're doing this. If you can condense steps, that's fine. I show every step so I don't lose anybody, hopefully. Okay. 8 minus 3 is 5. And then use your calculator. You're doing 2/5 times 5. Which, if you don't know, the 5's cancel. So it's 2 plus 3, which is 5. Try to find your y. So take a second, try to find your y. Because that's x. Yes, next one, say. We're going to do part.
Gotta find the y?
Yeah, now you gotta find y. So you're using the same formula. You're doing your ratio times the rise, which is y2 minus y1, and you're adding y1 because of where you started.
Is this already negative?
You are minus, yes, you're adding 1.
After we tried to.
Yep, as a coordinate. What'd you get? That's perfect.
So when you get the.
What'd you get? 5 what? No, not 5/9. Because it's from the initial coordinate where I started. So for your y, you add -1. Yeah. Yeah. People during the distance formula kept forgetting it's a minus and negative. So I'm going to put minus negative because the calculator will know that I'm adding them. So you need to bring down a 15.
Yeah.
Yes. 2/5 times 15 in a calculator. 5 goes into 15 3 times. 3 times 2 is 6. But if you don't understand the words that are coming out of my mouth, plug it into a calculator. Yeah, so it's 5 5. So P is 5 5. Because you're not plussing 3. You're plussing the y, which is -1. Oh, yeah, 2/5 times 5 because the 5's technically cancel. And if you don't understand that, use a calculator. 2/5 times 5. Boop. Is 2. If fractions hurt your brain, it's okay. They hurt mine too. That's why I use a calculator. You have 2 problems. That's all you have. You have plenty of time to do these in class. Do them now. And that way you won't have homework. You have 10 minutes. You have 11 minutes.
Oh, I get it. I get it.
That plus minute is not enough time.
Just try. Worst case scenario, you get it wrong, and then I'll laugh at you tomorrow.
Actually said it.
But like, you don't know anything. And then I'll be like, okay, let's fix it.
10:41, 30 seconds.
So try it. A little effort goes a long way. In 11 minutes. Huh?
K.
You have to draw a picture. When in doubt, draw it out. Ew. No, don't do that. Oh.
I think it would help me. It would help.
It's the ratio 3/4. I mean, E over that.
Yes. Look, you're learning.
I'm learning.
Oh my God, it's happening.
Bro, not be skinny again.